Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprint. So as we discussed in our previous video, we talk about resistor and capacitor, right? So today we are going to getting into deeper to understand about one of the essential component called transformer. So when we say transformer, we want to understand by definition what does mean by transformer. Transformer is an electronic device that can transfer the electrical energy between two or more coils through magnetic induction, and it is mainly used voltage step up and step down, and when there is a need of electrical isolation and impedance matching and power distribution and conversions. So basic working principle of transformer is it's an AC in primary coil that creates a changing magnetic flux in a core, induce AC in a secondary coil, right? So when we talk about different type of transformer, so by again, like as I said in my previous video, like again I'm classifying based on the construction and based on the usage. So when I say based on the construction, right? So it has been made with what type of core and shell type and toroidal transformer and planar transformer, right? By application, if you see, these transformers are mainly used in power transformers where there is a need of high power and substations, and distribution of transformer, isolation transformer and pulse transformer, audio and signal transformer. So one of the widely used application called switched mode power supply, where there is a high frequency transformer are used. Okay, so understanding that in a brief, let jump into the types of transformer parameters basically. So first thing is came like voltage rating. So both in primary and secondary, what is the voltage rating? So it indicates maximum safe operating voltage. Why it is important? It is important because it prevents the isolation breakdown. So when we are recommending an alternate solution, we should make sure that to find same voltage rating as an alternative solution or higher the voltage rating as an alternate solution. It should not be lower. So next comes the turns ratio, right? In the primary and secondary coils, what is the turn ratio? That we have to be maintain the same instead of going with the higher version. So because turn ratio depends on the frequency and application usage of the transformer. So next comes as a critical parameter called current rating. So current rating is maximum current that windings can deliver without overheating. So again, the windings are made with wire gauge. So basically they made with the copper or some other material, right? So as the properties of copper is, it is quickly absorb the heat and quickly absorb the coal of the properties. So wire gauge is one of the important parameter. It depends on that we are going to select the current ratings basically. So it has a equal cooling method and core saturation. When we recommending an alternate solution, we have to make sure that the replacement must handle equal and higher current rating. So that is a must. So next comes for Volt-Ampere rating. So this is one of the critical parameter. When I say Volt-Ampere rating, it's equals to voltage and the multiply with the current. So it's a combination of both. So that defines overall power capacity that transformer can handle. So when we are recommending an alternate solution, it must have greater than 20% of voltage ampere rating margin. That means we will get a high reliable output of the transformer, right? So next comes as an important parameter is called frequency rating. So transformer frequency are specific. So some of the common values which we use like 50 to 60 hertz for common power transformers, and for mid variant, when there is a need of system power supply, we use 20 to 200 kilohertz frequency. When it comes for anything behind greater than 200k and less than megahertz, right? So where we are using RF transformers. And why it is critical, right? So when we trying to understand why the frequency range is very critical, if incorrect frequency, then it's heating and core saturation inefficiency. It's cause for inefficiency in the field, in the transformer. So when we are recommending an alternative solution, it should match the frequency rating is mandatory. Next come to wonder to understand like how does the transformer made, for which type of material. So basically there are four materials type that we used, and again depends on the application and the requirement. The silicon steel material is used when there is a need of power and low frequency transformer, and ferrite transformers are used when there is a need of mid variant frequency range, which is nothing but SMPS, right? And next comes for nanocrystalline and amorphous. So it's a high efficiency application. These are the materials are going to use. Next comes for iron powder, where there is an RF choke transformer are required. So next comes to understand what is the solution. When we are recommending a solution, what is the rule that we need to follow when we are coming to this particular property. So the always I would say it should match or it should be exceed the magnetic properties like micro, beta saturation and losses. So turns ratio is one of the important parameter when we kind of selecting an alternate solution for transformer. It defines the voltage transformation. Let's say assume the input to the primary coil is around 230 volts as an AC, and output we expected to be around 20 volts or 23 volts. That depends based on the turns ratio. So the turns ratio is defined. For example, the input was, as I said, 230 is the primary input as an AC input. So that is 19 raised to 1. So the output would be like somewhere 12 voltage. So if I ratio up 19 is to 1, then the secondary voltage would be, AC voltage would be around 12 volts. So when we are recommending an alternate solution, right, the turns ratio must be identical for functional equivalence. So the turns ratio should be exactly same, should not be deviate. So next comes winding resistance and regulation. So what does mean by regulation? So regulation is a voltage drop from no load to full load. That means when there is a lower side of input is given, that is equal, that is good going to be a better performance, right? That is the regulation we are talking about. When we are selecting an alternate solution, select the transformer with equal or better regulation, right? So next comes insulations class and dielectric strength. So each dielectric has a different parameters. That common insulation classes are class A, class B, class F and class H. So when I say class A, it can be withstand around 105 degrees Celsius, and class B withstand around 130 degrees Celsius, and class F is withstand 155 Celsius. And likewise class H is at higher temperature range, which can be withstand around 180 degrees Celsius. So when we are recommending an alternate solution, it should be equal, or insulation class should be at higher side of it. If it is higher side of it, okay, the given temperature which can be withstand for a given application. Okay, so that is pretty much. And last one is nothing but leakage, inductance and coupling. So what does mean by leakage, inductance and coupling? So it affects the regulation, efficiency and noise. High frequency transformer requires tight magnetic coupling. So when I say tight magnetic coupling, the copper wire or any material that we are winding up on the magnet should be very much tightly coupled so that it meets the efficiency and noise reduction. So when we are recommending an alternate solution, it must be within plus or minus 20% of original spec. So every design when we made, right, so we should maintain that tolerance, right? So because why we want to maintain the tolerance, because each of the any component that we used, there should be falls within that tolerance range. So in summary, when I say as a parametric comparison, so again just to revise, benefit of you, so it says primary voltage. Why it is important means on the safety and insulation standpoint is really important, and allowed to be difference for alternate, it should be same on higher side of it. Secondary voltage functional requirement, it should be same, and when there is come for turn ratio, output consistency should match, the turns ratio value should be matched. And current rating is when temperature rises, there is should be an same and high, right? So Volt-Ampere ratings, as I said, it depends on the load capacity, the power capacity which can be withstand by the transformer. So always better to be recommended plus 20% as an higher side of it to keep the tolerance better. The frequency, avoid the saturation heating and it should be match. Frequency of primary and secondary coil should match. Core material, as I said, it should be better to select the equivalent one rather going with different materials. And as you know, mounting and size, always definitely you should see what is the parameter that should require as a mounting feature in the PCB or any of the chassis, that should be match, right? Yeah, I mean that is all about. So again, when we are recommending solution, these are the very much important parameters, and I hope this could help you lot to understand in better way what does mean by transformer and how critical this was. And equally, we are going to discuss more on to the of the transformer, how does it works and what is the application, where does it is used. In summary, so in summary, I would like to say the conclusion part of it. So that's wrap up our quick but complete explanation of transformer. If you're a design engineer or the component engineer, use the parametric checklist of safety evaluate and alternate transformer solution. If you found this valuable, please like, share, subscribe for more professional engineering content like this. I hope this help a lot to everyone. So I'm coming back with another follow on video called inductor. Thank you so much and have a great day.